Hello, everyone. Welcome back to my data demystification series. I remain your girl, Morola Care, fondly called Rolly. If you are joining us for the first time, I would like to say welcome to this series where we try as much as possible to simplify some of the complex topics in data management. Today, I'm going to be taking us a little bit away from the direction we've been going, and nothing to worry about. We're going to be going into the world of statistics, and of course, we will try as much as possible to simplify some of the terms that we also hear when we talk about statistical modeling and different things that happen within the profession or the field. So today, before I go on to the topic of today, I would like to ask for if you are one person that has ever wondered how the scientists or the people in charge of population or even researchers has ever come up with a figure when they say, for example, that the unemployment rate in America or in any other part of the country of the world is, for example, 3% or 5%. If you are one person that's ever wondered how they come up with these figures, then I think you may be interested in our topic for today. A few weeks ago, I actually got interested in this topic because a few weeks ago, a friend of mine just mentioned something like that, like, okay, so how did they come up with these figures when they say unemployment rate is 3%? Is it like they go around, do a survey, and ask everybody that is not employed, or how exactly did they come up with these figures? And so the topic of today addresses that. So I will start by trying to define what a population is. So when we talk about population in statistics, we are referring to the entire set. For example, if we have a country and if we want to refer to the population of a country, that means we're talking about everybody that lives in that country. So that's the population of the country. And so, still going back to that example of unemployment, if you're saying that for a particular country has unemployment rate of 3%, it doesn't mean that they go around and ask everybody living in that country if they're employed or not. And that will lead me to the second part of this conversation, which is sample. So basically what the researchers do is to collect a sample of the people living in that country, still going by the same example. And in this case, they would make sure that the sample is the full representation of the population of that country. And what I mean by that is representation in terms of the characteristics and the variabilities of the people that are living in that country. And so, still using the same example, if you want to do a research to know what's the unemployment rate in a country, we can be talking about, okay, so we need to know our sample must consist of women because we know that women live in this country. Our sample must consist of men because we have men that live in this country. The age also, age factor, just make sure that it has a rich representation of everything that is within that population. And so that's the only way that your sample is going to make sense or it's going to be able to infer what the population of that country is. And so once the sample is collected like that, there are different ways of collecting sample. What determines how you collect your sample is the kind of research or kind of business research that you are trying to do. You may be doing a random sampling, which is just to pick people from that population randomly and do your research or do your analysis on that sample. But in the case of unemployment, like the same example I've been using, you cannot do a random sampling. You are likely going to miss the very crucial information, or your output of that research may just not represent the entire population. And so, there's random sampling, there's stratified sampling. There are so many methods of sampling that a researcher would try to use depending on the kind of question that they are trying to answer. And so once the sample is collected, that is what is then used. Once you do your analysis, you process the data, you do all the data processing, the analysis, using the different statistical techniques that you may want to use, then that's the sample, the result of the sample is what is going to infer what is happening in the population. And that's how you will see the scientists, say that, for example, unemployment rate is 3%. It's a result that is generated from the sample of, or the subset of that population, which is then used to infer what is happening in the entire population. And so this will take me to just briefly talk about hypotheses. Hypothesis is some sort of guide that we use, that a researcher would use to define how they want to carry out the research, because usually there has to be a theory. And when you have a theory, you define your hypothesis based on that theory. And still using the same example, or let me just use another example so that we can understand this from another context. For example, if what we're trying to know is, or if we're saying that, okay, going to school or studying a course in science, um, people that study courses in science are successful in later in life. That's the theory, right? You don't have any base for that particular assumption, and so that's like a theory, like a something like an educative or educated guess that you may have taken at that point in time. And so that guess is what is then used to develop your hypothesis. There's something we call null hypothesis and alternative hypothesis. And so your null hypothesis is the first that guide. That is what you are trying to prove right or wrong. You said that people that study science are people that are successful in life. That's your first assumption. So that's what you're basing that analysis or research on. And so you get the data, you get the sample data, so then you do use some statistical techniques to analyze or to see whether or not your theory is actually accurate. That's your null hypothesis. So once you do your analysis, and if your analysis proved that theory to be wrong, then at that point you say that you would reject your null hypothesis. And so when you reject your null hypothesis, there has to be something else that is true. And so when you reject your null hypothesis, then you have to then fail to reject your alternative hypothesis. Alternative hypothesis is the alternative, as the word implies, the alternative of that theory that you've defined, which is your guide to your research work. So when you reject your null hypothesis, then you fail to reject your alternative hypothesis. I don't want to say accept, because in statistics we don't use the word accept your null hypothesis. You're not accepting, you just fail to reject it because it's not absolute. It is not absolute, so you fail to reject, not accept. That's the term used, even though in the very literal meaning, what you're doing is you're accepting the alternative hypothesis, but that's not how it is written or said in the statistical world. And so that's the easiest way that I can explain null and alternative hypotheses, which are the some sort of technique that you use, when you are carrying out your population sample and all that, to be able to, the process that you go through, let me put it that way, the process that you go through to be able to, use your sample to infer your population performance or whatever kind of research you're trying to do. And so that's that. And then also just to quickly mention type 1 and type 2 error. So when we talk about type 1 and type 2 error, what we're talking about is type 1 error is false positive, false positive. And what that means is when your null hypothesis, when you fail to reject your null hypothesis, when your theory is wrong, then you have committed a type 1 error, which is false positive. And type 2 error is the otherwise, so is the false negative. False negative, when you reject your alternative hypothesis, when in fact the theory or the assumption is right, then you have committed a type 2 error, which is type 2 error, which is the false negative. And so these are some of the terms that you will hear the statisticians use, or even people that researchers use, when they are carrying out some kind of research, or even business research. When you're doing a business research, these are some of the ways that you come to your conclusion. which is inferring the population from the sample that you collect. And your sample has to be a good representation of your population, and then also the statistical technique that you use. Few of the statistical techniques that we use is what I've mentioned earlier. I don't want to go into details because there's something called p-value and all of that, but of course that's the nitty-gritty of how you measure, which is not really our objective for this video. So thank you very much once again for joining us today. I really appreciate you, and you can look forward to another demystification of data management terms, in our next video next week. Thank you, and enjoy the rest of your day. Bye bye.